So, hello students, welcome once again to Dr. Shoraf sir classes. As we know that we are solving the paper of this UPSC CSC, the Civil Service Examination, and this is the mathematics paper, optional paper of 2021, and we are solving the paper 1. As you know that we have already solved this question number 1, this ABC in the previous video. So in this video we will solve this question number 1D. So it's given that what is the question. Let's see the questions. Show that between any two roots of e to the power x cos x equal to 1 there exists at least one root, that is e to the power x sin x minus 1 equal to 0. Right, so you have to find this, we have to prove this. So let us consider that. Okay, so we can take like this. So let a and b are the two roots of the equation e to the power x cos x equal to 1, right? So then we can write, since a and b are the roots, so then we can write this e to the power a, so it will be e to the power a cos of a, so it is not alpha, cos of a equal to 1, and similarly another root e to the power b cos b equal to 1, right? So let f, we define a function, so let f be the function. Let f be the function defined as this f of x is equal to e to the power minus x minus cos x. So let us take this f, that f be the function by this, where fx is defined as this, okay, e to the power minus x minus of cos x. So now from here we can see that the first one is that fx is continuous, right, in the interval, in the closed interval a comma b, right? And this we have defined the e to the power minus x and cos x, these are both continuous functions, right? Now point number 2 is that if we do the derivative, that is f prime x, it will be minus of e to the power minus x plus sin x, right? So therefore this f, this function is also differentiable. This f of prime x is also differentiable in the open interval a comma b, right? So that is one of the thing. This is the second observation that we find. Now observation number 3 is that f of a, if we put f of a, so it will be e to the power minus a minus of cos a, not alpha, sorry, so cos of a, this. So we can write this as e to the power, if we just take e to the power minus a as common, so it will be 1 minus e to the power a cos a equal to 0, okay? And then f of b will be, if we put the same thing, f of b, it will be simply e to the power minus b minus of cos b. So similarly we can take this e to the power minus b as 1 minus e to the power b cos b, okay? So it is equal to 0. So we can infer that this f of a is equal to f of b, which is equal to 0. So thus fx satisfies all the condition in the Rolle's theorem, right? So we can infer from here that fx, this particular function satisfies This satisfies all the condition of the Rolle's theorem. So for the proper answer you have to write in words. So in the interval a comma b, right? So this is the thing. So there, so since fx satisfies all the conditions of the Rolle's theorem in a comma b, so there exists at least one value of x, right? So there exists at least one value of x. So that will be in the open interval, that is a comma b, and such that we have this f prime c is equal to 0. So we have taken that f of x, f prime x is equal to, we have already defined, so it is minus of e to the power minus x plus sine x. So f of prime c, f prime c can be written as e to the minus of minus e to the power c minus plus of sine c, which is equal to, we can take it as 0. So from here we can simply write this, that okay, so let us take in this manner. So we can write from this equation that minus of e to the power minus c plus of sine c is equal to 0. So from here, okay, is equal to 0. From here we can write this minus 1 plus e to the power c sine c. Let's take this in the loading. So we can write it as, so we can write it as minus 1 plus e to the power c sine c is equal to 0, or we can write it in this manner, that e to the power c dot sine c minus 1 is equal to 0, right? So whatever we find, that from here we find that c is the root of the equation e to the power x sine x minus 1 equal to 0, right? So hence between any two root of the equation we have proved that, so we can write it in words also. So yes, so here we can write in this manner, that the final answer, hence between any two roots of the equation e to the power x cos x is equal to 1, there exists at least one root of the equation e to the power x sine x minus 1 equal to 0, right? So this is the answer for the question number 1D. Okay, so let's move to the next question, the last part of this question number 1, that is 1E. So this is question number 1E, that is the last part of question 1. So it is given that find the equation of the cylinder whose generators are parallel to the line, that is given as x equal to minus y by 2 equal to z by 3, and whose guiding curve is x square plus 2y square equal to 1 and z equal to 0. Okay, so let us take this, we have to find the equation of the cylinder from here. So let us take start this question. So solving this, so let me consider a point P where P, the coordinate is x1, y1 and z1, be any point on the cylinder. Okay, this is any point on the cylinder, and then the equation of the generator will be, so then the equation of the generator through P, so then the equation of the generator through P, it will be x minus x1 by 1 equal to y minus y1 by minus 2 equal to z minus z1 by 3. So that is equation 1. Let us take this as equation 1. So this generator meets the plane z equal to 0. So this is this equation 1. So this generator meets the plane at z equal to 0 in point given by, so it is x minus x1 by 1 equal to y minus y1 by minus 2 equal to, it will be z minus z1, that is 0 minus z1 by 3, right? So that is in the point, we have to find the point. So the first point is x1 minus 1/3 z, comma, that is, it is z1 actually, okay, y1 plus of 2/3 z1, and the z is equal to 0. So that is the point. So this generator, that is the equation 1, this the generator equation, it intersects the conic if the locus of P, that is x1 with the coordinate x1, y1 and z1, or the required equation of the cylinder will be so the required equation of the cylinder, it will be, so we can write this as so these are the points given. So x1 minus, so we can simply write it as this. So it is written as x minus 1/3 z whole square plus twice of, because 2y square, so y plus 2/3 z whole square equal to 1. So simplifying this, we can write this is as x square plus 1 by 9 z square minus 2/3 xz. Okay, you can write it as plus of 2. Simplify this, so it will be y square plus 4 by 9 z square plus 4 by 3 yz, right? It is equal to 1. Now further simplifying this, we will find that it will be 9 of x square plus z square minus 6z, if we simplify this side, plus it will be 2, this means it will be 18y square plus 8z square plus of 24 yz minus 9 equal to 0. So after simplifying x, z, x, y and z, so we can write this as the final equation as this. So it will be 3x square plus of 6y square plus 3z square minus of 2xz plus 8yz minus 3 equal to 0. So that is the equation. So this equation you have to find. From the question you have seen that find the equation of the cylinder whose generators are parallel to the line. So this is the equation of the cylinder. So question 1 has 5 parts, that is 1a, b, c and d. So we have solved this question number 1. So let's move to the next question. See you in the next video.